Okay, class, today we are going to work on some of the word problems from chapter 3, and I'm going to focus on an example that has to do with radioactive decay. Okay, so for this problem we have a radioactive isotope called radon-226. Radon is a gas that's naturally occurring in the ground, and it is known to have a half-life of 1,620 years. So what that means, for the half-life, if you initially start out with a amount, right, like 10 grams or something, then after 16-20 years, the amount you're going to have is A over 20, because it's half-life. It's the amount of time it takes to get from this much A to that much A over 2, 1/2 of A. Okay, so radon-226 is the name, and this would be the abbreviation for it. This 226 doesn't really have any numbers pertaining to what we're going to be doing in the problem. It's just the name of the type of gas. Okay, so we know that the half-life, the time it takes to go from amount A to amount A over 2, is 1,620 years. The other bit of information we're given is after 1,000 years, there's 1.5 grams. So that's going to give us another kind of XY pair for our time and then an amount. And so what we want to know is the decay rate. So this is an example of an exponential decay problem. And the generic equation for an exponential decay problem is y equals ae to the bx, where y will be the end amount after t years, or x years in this case, because we're going to have x is the number of years. B is the rate. If it's a growth rate, B will be positive. If it's a decay rate, B will be negative. So it's always going to be in decimal. And then my A, which we have here, is the initial amount. So y is the initial amount. Okay, so this can also be used in money. For example, if you put initially $10,000 into a bank and it's going to grow at 3% interest a year, we can find out how much Y we have at the end of, say, 15 years. Or if we bought a car, so the initial amount of the car might be $20,000, we can find its decay rate if after 10 years the value of the car is $5,000. Okay, so we can have things growing and decaying. Okay, so what we know is that we have this radioactive isotope has a half-life of 1,600 years. So what that tells me is if we start off with A, at the end of 16-20 years, the amount that we're going to have Y, the end amount after 16-20 years, is going to be A over 2. So we have e to the bx would be 16-20 years. So all I did was I plugged in after 16-20 years, we're going to go from an initial amount A to an end amount A over 2, because y is our end amount. So we're going to end up with half as what we started with in 1,620 years. And since we're going to be decaying, our b is going to be a negative number when it comes out. Okay, so the way our book does is they make it be a negative because it's decay. If it's growing, it'll be positive. Okay, so what we can do is we are going to solve for B, our unknown decay rate. We want to find our rate, which is B. So what I can do is I can multiply both sides by 1 over A. So if I multiply by 1 over A here and 1 over A here, notice that the A's cancel out. And I'm left with 1/2 is e to the minus b times 1620. So it really didn't matter what A value was, what the initial amount was. I just know that what I have now, 1, is going to be after 16-20 years, 1/2 that amount. That goes back to the half rate problem. Okay, so now I have an equation. So we can get rid of the 1, and I want to get the b. That's what I'm solving for. So we have an exponential, base e, and I want to get the exponent. So the way we undo an exponential is we take a logarithm. And since this exponential is base e, I'm going to take the natural log of both sides, because the natural log is log base e. So I'm going to take the natural log of e to the minus b times 1620. So my e and my natural log cancel off using the properties that we discussed last time. And so I have the natural log ln of 1/2 is minus b times 1620. And I want to solve for b, my decay rate. So I'm just going to divide both sides by negative 1620. And I wrote 1 over n. It should say 1 over 2. Just doesn't look like a 2. So now I can plug this into my calculator, and I get this exact number. B is the natural log of 1/2 over minus 1620. Or I get that this is about 0.000428. So we get that on the calculator, the way it shows up is 0.427866863 e to the minus 4. Remember that scientific notation that tells you to move the decimal place over 4 spaces. So it's 0.000427 and so on. And if we want to find the percent, and since we want to find the decay rate, we want to find the percent. So to find the percent, you multiply it by 100, which gives us to 0.0200428. I can't say this right. We multiply it 100, and we get that it's 0.0428% would be the decay rate. We're going to use this in the second part of the problem, and we're actually going to use this actual number for b in part B, not the rounded one. I want to use the exact one. So let's go ahead and move on to the next slide, which has the second part of the problem, which is what is the initial quantity of the radon. So we know that the decay rate is 0.0428%. Okay, so the exact value of our B that we got out, ln of 1/2 divided by negative 1620 was our decay rate. And we also want to know, we're going to use the other bit of information that we haven't used that in the problem that said after 1,000 years, so that's a time, so that's an x, 1,000 years, there was 1.5 grams of the isotope left. So what we ended up with, our y, was 1.5 grams. So remember our equation, y equals ae to the bx. If it's decaying, our b is negative. If it's growing, our b is positive. So y is how much we end up amount. So our end amount. X is our time. B we found in the first problem, and we want to know the initial quantity, which is our A value. So we're just going to plug in what we know. So 1.5 is how much we end up with. A, we don't know our initial quantity. E to minus B, and I'm going to use this whole number. So that's going to be my exponent minus the natural log of 1/2 over minus 1620 times x. My x is 1,000 years. So all of this is the exponent. Okay, so I have 1.5 equals AE in this huge exponent thing. So my negatives are going to cancel, and we're just going to do a little bit of math. So we want to solve for A, so this whole thing here is a number, e to something. We could just type this directly into our calculator. It's a number, I don't know, 5. We want to solve for A, so we're going to divide everything by that. So we have A is 1.5 all over this thing. So I'm going to divide both sides by this thing. I'm going to be left with A, e to the, and I'm going to cross off those negatives, ln of 1/2 over 1620 times 1000. And this is the initial amount. So I can just plug that into the calculator directly. What I get out is 2.300976822. You really should pull out your calculator and make sure that you can plug this in and get out exactly what I do. We of course don't need to round to so many decimal places, so I can say that this is about 2.3 grams. So the initial quantity of radon 226 was about 2.3 grams. Okay, so there you have it. So I would like you to make sure you can practice using this on your calculator, otherwise ask me in class. So go ahead and practice using your calculator. Remember, word problems have sentence answers, and I will see you in class. Have a lovely and relaxing evening.